All right. Hello, everyone. It's Mr. T checking in. This is first trial version of doing this recording thing. Borrowed a friend's iPad and Apple Pencil. We're going to see how we can make it work. So this is lesson number 42 on solving with property of equality. So funny thing, I actually recorded this whole 20-ish minute lesson, and then I realized I did it all with no sound. So I'm learning as we go. Hopefully this one works by the end. What I would encourage you to do is go back and look at the notes number 39, 40, and 41 just to review exponential and log. Before the break, we kind of looked at the graphs of them, the transformations, how to rewrite from exponential to log and log to exponential. And so that would just be helpful to kind of set up. The next couple of weeks, we'll be talking about how to solve exponential equations and how to solve log equations for x in equation. So just heads up, that's where we're headed. I thought it'd be good to start with a quote. We had begun talking about our four goals. We were on, I think, build character. We were talking about never give up the next day, but we'll revisit that when we get back together. But just thought it'd be good to start with a quote or like a brain teaser sometimes at the beginning of a lesson. So this quote stuck out to me in this time, so I thought I'd share. So it says, "Anyone who says sunshine brings happiness has never danced in the rain." Take a minute to think about what that means to you. You can pause the video if you want. When I was listening to this, when I heard this quote, I kind of thought about, like, generally there's a saying that, like, sunshine brings happiness, right? Which is true statement, I guess, depending on who you are, right? Some people like the rain, some people don't, but generally speaking, more people like sunshine than rain. And so this kind of just this idea that rain in life, thinking like rain representing hard times and like sunshine representing good times, I think about like you can still kind of dance or celebrate or learn from or find purpose or in low seasons or in hard seasons, like you can still learn from those and like push through those, and it shapes you as a person and shapes you as who you are. And so just thinking about that, I was thinking that in light of the whole coronavirus and staying at home thing, and just thinking about like what could we take from this, or what could we, in the midst of the kind of challenges or in the midst of the hardships, like what could we still see positive things in it, I guess. And so certain things I was thinking about was like for myself, like being able to spend more time with my family. It's just been really sweet. Or just being able to rest or just pause. Like just felt like I was on go mode. Just being able to just pause and just take a moment to force pause has been good. And learning technology and how to do this has been a good thing. And so just think about for yourself, I guess, what could you make out of this this season of maybe feeling like rain, I guess. Maybe it's spending more time with people. Maybe it's picking up a hobby that you enjoy. Maybe it's, I don't know, whatever for yourself. Just thinking about that. So just want to share that. We would always say our four goals in class, so I just thought it'd be good as a reminder to even do that here, or just say them. So we will learn math, build character, never give up, and ask why. Just want to keep that in mind as we go through this. So the lesson, like I said, was on how to solve exponential and log equations using what you call the property of equality. So we're going to start with some simple examples here. So let's say we have 7 to the power of x equals 49, and we're trying to solve for x. So we can kind of know that in our heads. 7 to the power of what number equals 49? And we would say 7 to the power of 2, right? Because 7 times 7 is 49. So if 7 to the power of 2 is 49, then therefore this, let's do red, this x is 2. So x equals 2. That's an easy example. We can just look at it and tell, right? Another way to think about this, and this is going to be more helpful for when the problems don't become as simple where you can just do it in our heads, is what you call the property of equality. So that would say, if this base is 7, you would want to get this 49 to have a base of 7 as well. So we can make that 7 to the power of 2, because 7 to the power of 2 is 49. This would be 7 to the power of x. And so the basic concept with the property of equality is that if you have an equal sign here, if this base and this base are the same, they are equal, and that means that this and this have to be equal. So you can remove these bases here and just say that x equals 2, which is the same thing that we get over here. So basic premise is if these bases are the same and they're equal, then the exponents have to be the same. So this one over here, bases are the same, 2 and 2, and they're equal, so that means that x equals, bless you, my wife just sneezed. So the property of equality states that if the bases are the same, then exponents equal each other. So these exponents have to be equal. So that's a basic premise of the property of equality. I don't know why I erased that. I'm so used to erasing after I'm done. I could just switch to slide and it's gone. Used to my regular whiteboard. Okay, so let's try an example. So let's say we have this. 2 to the power of x equals 8 to the power of 3. And we're trying to figure out what value of x will make this statement true. It's a little bit harder to tell in our minds because we would first have to know what is 8 to the power of 3, right? So what we want to think about here is how can we use the property of equality to make the bases the same first. So if this base is 2, and we want this base to also be 2, we would basically take this 8 and rewrite this as 2 to the power of what number here would be 8. And we would say 2 to the power of 3 is 8. So all we're doing is rewriting 8 as 2 to the power of 3, because 2 to the power of 3 is 8. Then we still have this 3 out here. So we're going to take that 3 and put it out here. And we're just going to bring this down because we didn't do anything with that. Okay? So we really haven't changed anything. We just took this 8 and made it 2 to the power of 3, right? Didn't change what it's equal to. But this helps us because now we have the same base. So now we need to deal with this right here. So what we do with that is we would multiply, because when you have an exponent to an exponent, you multiply. So 3 times 3 would be 9. So 9 is the new exponent. And so we have 2 to the power of 9 equals 2 to the power of x. So now, because the bases are the same, we would use the property of equality, which would say if the bases are the same, you have an equal sign here, then that means that these have to equal each other. So x equals 9. Now, a way that you can check that is you could take that 9 and you can plug it back in here for x, and you can see that 2 to the power of 9 would equal 8 to the power of 3. So that's the property of equality. Okay, let's try another example. Okay. So let's say we want to solve this for x, and we're adding a little bit more to it. So first step is to see, okay, we need to it's a little bit hard to just kind of figure out what numbers could we plug in here that will make it true. So we want to use the property of equality since we see an equal sign. So we see this is a base of 2. It's easiest to take the bigger one and try to make it into the smaller one, generally speaking. So if we want to make this 4 have the same base, we would change that 4 to 2 to the power of what? To the power of 2. Beautiful. Okay, so 2 to the power of 2 is what we're changing 4 to. Now all this right here, we can't get rid of it, so we need to keep it up here, still in the exponent. And then this right here, we're going to bring down because we didn't do anything with that. So now we have the same base, but before we deal with that base, we need to multiply these. And keep in mind, we need to distribute this 2 before x. 2 times -1 would be -2. And so we just multiplied this 2 into both of these. And then this 2 we're going to bring down. And this we're going to bring down. Oh, that's a bad equal sign. Okay, so then we remember that if the bases are the same, we can use a property of equality, and therefore the exponents have to be equal to each other. So we don't even have to worry about the base. We can go ahead and say 4x minus 2 equals 6x. And that is an equation that we can now solve for x. However you want to, we can subtract this 4x if we want. We get negative 2 equals 2x. To solve for x, we're going to divide by 2. We're going to get x equals negative 1. And again, the way we can check that is if we plug that negative 1 in for x here, and here you can see if the statement is true. Let me pause there. Here's where the beauty of this is that you can rewind if you need to. If I went too fast, because sometimes I get too excited about math, or if you didn't understand it, pause, rewind, do what you need to do to make sure you understand the material. Okay? All right. That I need to erase because that was there from my first attempt where I didn't record my voice. All right, so last case of exponential, then we'll talk about log. What if you wanted to solve this for x? So the difference here is we have some stuff on the outside. So first we would need to remove those and just get the base to the power of exponent by itself. So we're going to subtract 4 first. It'll be 8 times 2 to the power of x plus 1. 5 minus 4 would be 1 here. Then to remove this right here, we need to divide by 8. So it'd be 2 to the power of x plus 1 equals 1 over 8. Now, we have the base and the exponent here by itself. So now we need to make this have the same base as this. So the way we're going to do that is we need to make this 1 over 8, 2 to the power of something. So 2 to the power of what is 1 over 8? This is where you kind of have to think back. We talked about this briefly before spring break. If you have a fraction, you're trying to figure out 2 to the power of what is that fraction. You know that this has to be a negative number, okay? Because let's say you have, and this is sidetracking, but just to help you understand, this would end up being negative 3, okay? So this is going to be negative 3. Okay, let me try to explain why. 2 to the power of 2 is 4. 2 to the power of 1 is 2. 2 to the power of 0 is 1, right? When we go 2 to the power of negative 1 is going to be 1/2, okay? Because as we go this way, we're dividing by 2. So then when you go 2, 1, 0, and then you keep going, you have negative 1. So now you keep dividing by 2. 1 divided by 2, if you kept going, would be this 1/2 here. And then if you kept going, 2 to the power of negative 2 would be 1 over 4. And then you kept going like that, okay? So, or if that's confusing, just think about it this way. 2 to the power of negative 3, all you really need to do is just take that. It's going to go as a fraction. This whole thing is going to be 2 to the power of 3 with a 1 at the top. So that's going to be 1 over 8. So like if you had 2 to the power of negative 4, it would be 1 over 2 to the power of 4, which would be 1 over 16. So when the exponent is negative, it ends up becoming a fraction, okay? All right, so basically, back to this problem. 2 to the power of x plus 1 equals 1 over 8. So 1 over 8, when you make it the same base, is 2 to the power of negative 3. We're going to bring that down. It's going to be 2 to the power of x plus 1. Now that the bases are the same, we can use the property of equality. The exponents are now going to be equal. So it's going to be x plus 1 equals negative 3. When we subtract 1, we're going to get x equals negative 3 minus 1, that's negative 4. And again, we can check that by plugging this back in for x and seeing if the statement is true or false. Okay? All right. Now let's talk about logs, solving logs. This right here is a refresher from before spring break. I want to make sure you remember how to rewrite in log form. Just as a reminder, log base b of x equals y. If you rewrite that in exponential, this to the power of that equals that. It's like a circle, right? So for rewriting this first one, which says log base 4 of x equals 2, it will be 4 to the power, this is a solve for x, it will be 4 to the power of 2 equals that x So x equals 16 because 4 to the power of 2 is 16 because 4 times 4 is 16. If you want to do this one, log base 3 of 9, you want to know what that equals. You put x here. Again, it's like a circle. 3 to the power x equals 9. So then 3 to the power of what number is 9? And it will be 2 because 3 to the power of 2 is 9. I meant to mention this at the beginning of this video, but I forgot. So these notes are on Google Classroom, right? So you have two options. You could either be writing this on the notes if you're able to print it. If you're not able to print it, when we come back to school, I will like make copies of filled in notes and like give it to y'all. But I would recommend that you write this on a notebook paper so that you have notes for when you do the practice. So either you look at the notes that I put on Google Classroom, you follow along on this video, and then you copy the notes if you're able to print it out. If you're not able to print it out, totally fine. Write the notes on a sheet of paper so that you have notes to refer to as we're doing practice and as we continue to work on these problems, okay? Sorry, I meant to mention that at the beginning. All right, so on this one, the base, remember when we're on the third one now, log of x equals 2. The base is 10 whenever there's no base there in this log. If we rewrite that, it'll be 10 to the power 2 equals x. So x equals 10 to the power 2 is 100 because 10 times 10 is 100, okay? Last one over here, 10 log base 2 of 1. You're trying to find out what this is, so this is x. So 2 to the power of what is 1 when we rewrite it? So 2 to the power of what number is 1? You got to think back. We talked about this before. So what is 2 to the power of what is 1? Ah, very good. Great answer. I know that y'all got that right. 2 to the power of 0 is 1. So x equals 0 is what that would be. Okay? All right. Let's go to number 9. All right. So now that was just a refresher on logs. Let's talk about the property of equality. Similar concept. Let's say we have this log base 5 of x equals log base 5 of 8. We are solving for x. Because the bases are the same, therefore what is in parentheses have to be the same. So x equals 8. That's the basic concept. Remember, the base is not there, it's 10. The bases are the same. What's in parentheses has to be the same. So x equals 10. So the property of equality states that if the bases are equal, the bases are the same, then this shouldn't say x's, whatever's in parentheses. Let's say whatever's in parentheses equals each other. Okay? All right. Let's actually try two last problems on property of equality, and then y'all can practice. So we have log base 5 of 5x plus 3 equals log base 5 of 18. And let's say we want to solve this for x. What we want to think about is it easier to use the property of equality, or is it easier to rewrite this in exponential, right? And so thinking about it, we can see, all right, I don't want to rewrite in exponential because if we do that, then it's going to be like 5 to the power of log 5 of 18 equals that whole thing, and that's just a lot. So we're not going to do that. Oh, that's not the eraser. What is that? So we want to see, okay, we can use the property of equality because we have an equal sign here. We have log and log, same base. So if that's the case, that rhymed, then we can go ahead and set this equal to each other. 5x plus 3 equals 18. So if we have 5x plus 3 equals 18, then we just solve that for x, right? So it's minus 3 minus 3. 5x equals 15. Divide by 5, because it's being multiplied, that's going to be x equals 3. So beautiful, x equals 3 is our answer. Now, with the log, it's important that you actually always check your answer by plugging it in, because it is possible that we get an answer and that answer is false when we plug it in. So it's important, again, to check your answer when you're solving log. So to check that, we're plugging in 3 for x. So it'd be log base 5 of 5. And then because we have an x here, we're plugging in 3 plus 3 equals log base 5 of 18. So then this 5 times 3, 15, plus this 3 right here, that's 18. So we have log base 5 of 18, right? Equals log base 5 of 18. Is this statement true? Is log base 15, or sorry, log base 5 of 18 equal to log base 5 of 18? The answer is yes, so our answer is true. Beautiful. That's how you solve a log with the property of equality. One last one. We have ln, we have x squared. It looks confusing, but it's not. We can do it. All we need to do is the property of equality. The base is e, right? Remember, when it's natural log, ln is natural log, the base is e. They're the same, so we can use the property of equality. So therefore, this and this have to be equal to each other. So we can just go ahead and say x squared minus 4 equals 3x, according to the property of equality. So if we solve this, if we want to solve this for x, we need to take note of the fact that we have an x squared. Because we have an x squared is quadratic, because it's quadratic, more than likely we're going to have to factor. And when we factor, everything needs to be on one side. Factoring, yes, it's been too long. It's been too long. I know y'all miss factoring. So we need to move this 3x over, so we're going to subtract 3x. So it's going to be x squared minus 3x minus 4 equals 0, right? And so looking at this, we can factor it. Remind me what we use. We use the x method, so we're going to put that on the side. A times c goes at the top. A is 1. C is negative 4. We're going to multiply that. It's going to be at the top, negative 4. B goes at the bottom. The B is negative 3. So we're looking for what two numbers multiply to give you negative 4 and add up to give us negative 3. That's going to be negative 4 and 1. And then last step, you divide by the A. The A is 1. That's going to be 1, and this is going to be negative 4. So the factor is x minus 4 and x minus 1, right? Equals 0. So then to solve that, we're going to end up with two answers here. We're going to have where x minus 4 equals 0 and where x minus 1 equals 0. So that's just 1, or you could just do the opposite, right? That's 4. 4 and 1. Something's wrong. I did something wrong. I don't have someone to tell me if I made a mistake like y'all. All right, 1. That's plus 1, right? So this is supposed to be plus 1. So this is supposed to be plus 1. I'm sorry. This would be minus and minus. So this is minus. My bad. X equals negative 1. Okay. Now, if we look at our answers, we have 4 and negative 1. If I confuse anyone, I'm going to write that back because I made a mistake. Right here, this was negative 4 times 1. Negative 4 times 1 multiplies a negative 4, right? My wife is laughing at me. She heard me say that I made a mistake. So negative 4 times 1 is negative 4, but when I wrote it down right here, I put minus 1, but it was supposed to be plus 1, okay? All right. So we have negative 4 and negative 1, but if you look at the answer choices, I'm sorry, 4 and negative 1, but if you look at the answer choices, we have 4 and we have negative 1. Why do we think that is? Okay, good. Because that means one of them is false. That's why I said we always have to make sure that we plug in to check to see if our answer is true or false, right? So I'm going to go ahead and go back in and plug it in. Let's try 4 first. If we plug in 4 for x, it'll be ln of 4 squared minus 4 equals ln of 3 times 4. Just plugging in 4 for x, that's going to be ln of 4 squared is 16, right? And then 16 minus 4 is 12. 3 times 4 is 12. That is true. 4 is true. We can assume negative 1 is false, but we need to make sure, and this is an important point to talk about. So let's say we plug in negative 1. We're going to have ln of 3 times negative 1. That's if I plug in negative 1 for x here. If I plug in negative 1 for this x, the ln of negative 1 squared minus 4, right? Negative 1 squared is 1, because negative 1 times negative 1. We're going to have ln of 1 minus 4 is negative 3. 3 times that is also negative 3. This looks like it's true, right? ln of negative 3 equals ln of negative 3. However, this is an important key point. The way that you know as a shortcut that it is false is if when you plug it in, what you're left with in parentheses is negative, and you have a log here, it is false. You cannot take the log of a negative number. So this is false, even though it looks like it's true. So be careful there. How do we know that it is false? Why can you not take the log of a negative number? Let me erase all these stray marks for those of you who always mention that I don't erase well and it bothers you. There we go. Beautiful. So let's just talk about that. So the answer was 4, right? Because negative 1 was false. But let's just talk about that real quick. Let's say you want to find log 2 of negative 8, log base 2 of negative 8. That's not possible because we see that there's a negative in the parentheses and there's no x. So the reason why that is because let's say we try to actually solve it. 2 to the power of what number is negative 8? Nothing. It's not possible, right? Because you might think 3, but 2 to the power of 3 is 8, positive number. You might think negative 3, but 2 to the power of negative 3, remember we talked about this earlier, if the exponent is negative, it becomes a fraction. So that is 1 over 2 to the power of 3, which is actually 1 over 8. So it is not possible to take log base 2 of negative 8. All right. Thank you for listening and for writing notes and following along and being flexible and not giving up and learning math and building character and hopefully asking why. Here's the next steps. If you have questions, feel free to message me on Remind. Feel free to join our office hours on Zoom, which I'll send out a link for this week. Feel free to send a Google Classroom question. Here's the next steps. What I'd like for you to do, hopefully you're writing notes on these. I'd like for you to make sure you do the practice by Friday at 4:20. That's when it's due. I'm going to send it. There's another video after this. I will watch that and then do the practice for both of them. Yeah, enjoy your day or night whenever you're watching this. I will talk to y'all later. Bye.